Hello everyone, today I'm going to introduce the inhibition of methanogenesis by propionic acid. And as you know that propionic is one of the volatile acids that produced during the acidogenesis of pollutants or of feedstocks inside the digester. So what happened here is that a number of methanogenesis was negatively affected at propionic acid concentrations between 1500 and 2200 milligram per liter. And here, this blue here, you can find the references of this articles here that you can read more about this topic. And the propionate concentration of up to 8000 milligram per liter can be tolerated, which means that bacteria and archaea may be adapted to this high concentrations of propionic acid. Of course, the inhibition is drastically increased with the reduction in the pH, because basically the unionized form of propionic acid is increasing, and the unionized form of the propionic acid is the most toxic form of propionate inside the digester. Of course, again, propionic acid can also inhibit acidogenesis, but this is not really the topic for today. And of course, with acclimation of bacteria and archaea, they may actually be able to withstand high concentration up to maybe 8000 milligram, as I mentioned earlier. Okay. Besides that, I'm going to also introduce you to how to calculate the unionized propionic acid. Basically, to calculate the unionized form of propionic acid, we use this kind of dissociation of different acids, and this is basically the equilibrium. At the equilibrium, we can actually calculate how much of the propionate is presented as an ionized propionic acid. Here is an example from Dr. Speece's book, and here this is the reference. You can find this reference there. You can find this example there. And here, this is how to calculate the concentration of ionized propionic acid for a total propionate, a concentration of 5000 milligram per liter, if the pH inside the digester is 7 or pH equal to 7. So as you know that the ionization of propionic acid is here, this is the unionized form of propionic acid can be in equilibrium with the ionized propionic acid. And of course, we have here the concentration of a hydrogen ion. Basically, this is a measure of the pH. If we consider actually the pH is equal to pKa, and the pKa here is the quantitative value for the strength or the weakness of an acid, plus a log or the logarithm of the Br dash, which is the ionized propionic acid concentration, divided by the unionized propionic acid concentration inside the digester. Of course, to get the value for the ionized propionic acid, which is Br minus, we have to use the total propionate in the reactor, which is TBr minus the unionized propionic acid. And in this case, we can calculate how much we have an ionized form. So if we have actually the equation again, this equation can be written as Br dash is equal to the total propionate minus the unionized form of propionic acid, divided by, of course, still the same thing if the unionized form of the propionic acid. And after simplification, we can get to this equation. And here, this is TBr, which is the total propionate inside the digester. And the total propionate is equal to the ionized propionic acid plus the unionized form of propionic acid. So with that, we can actually have this kind of equation. We can say that the concentration of the unionized form of propionic acid equal to the total concentration of propionate inside the digester divided by 1 plus 10 to the power of pH minus pKa. And again, this is pKa, this quantitative value, and pKa actually can be used to calculate the dissociation factor for the acid, which is Ka only, and Ka is equal to 10 to the power minus pKa. Okay, so here this is basically we can substitute different values, and we have here the total propionate inside the digester is 5 gram per liter. We can convert this to moles by dividing it to the molecular weight of propionic acid. It can give us 0.067 mole per liter, and then we can actually have this value as TBR. This is basically how many moles, and divided by 1 plus 10 to the power of 7 minus 4.86, which is, this is basically the pKa for propionic acid. With that, we can get how many moles. It's 0.00485 mole per liter, and we can also convert this molar to grams by multiplying by 74 with the molecular weight. So basically here we have how many gram per mole. 74 times 0.0048 give you the how many grams of unionized form of propionic acid. We get this actually also can convert it to milligram per liter. This one actually, this is very simple example to show you even here. The pH, of course, can play a big factor in this case, and we can say that the more actually you have the pH, if you have a different value for pH, you can just substitute the value for pH, and the less the value for the pH, the more unionized form you will get, which means that the inhibitory effect will be increasing. The inhibitory effect of propionic acid will be increasing by decreasing the pH. With that, I would like actually to stop here and thank you. And if you have any comment, yeah, just please let me know. And with that, I will see you next time.